Good afternoon, ladies and gentlemen. I'd like to say thank you for your participation from various countries in the world in the 9th Tokyo workshop hosted by Asia Heat Pump and Thermal Storage Technology Network. This time, the workshop will be conducted online because of the COVID-19. My name is Koki Watanabe from Heat Pump and Thermal Storage Technology Centers of Japan. I'll be the moderator for this event. So first, there are 3 points I'd like to mention to you. The first point is the language switch. Today's workshop will going to provide simultaneous interpretation both in Japanese and English. So you see the interpretation button at the bottom of the screen. You can choose either Japanese or language. So please choose the language you want. The second point, how to ask questions. When we have time for a question and answer session, there's a hand raise button at the bottom of the screen. So please press that button. You are not going to use the Q&A button and send us the text question. So make sure you press this hand raise button and we'll designate you so that you can give us questions verbally. The third point, downloading of the presentation materials for today's workshop. So you can see the URL in the chat, so you can download the materials from that URL. Those are the 3 important points I'd like to mention to you at the beginning. Well, first of all, we'd like to have the opening remarks from Mr. Hiroshi Komiyama, who's the chair of the Heat Pump and Thermal Storage Technology Centers of Japan. Good afternoon, ladies and gentlemen. I'm Hiroshi Komiyama, chair of the Heat Pump and Thermal Storage Technology Center of Japan. Well, at the beginning, I'd like to say thank you very much for your participation today in the Asian Heat Pump and Thermal Storage Technologies Network Tokyo workshop. Because of the COVID-19, we'll have this workshop online this time. Well, Asia Heat Pump and Thermal Storage Technology Network was established in 2011, so it's been 10 years since then. There are 7 participating countries. And in October 2017, we held Tokyo workshop and penetration and promotion of heat pump water heater in Asian region and positioning of renewable energy to realize it was mainly discussed in the workshop, and that was adopted as a Tokyo Declaration. And today we will hear from presenters on the current situation based on the Tokyo Declaration, and major topics in each country will be presented. Also, in this workshop, we will have 2 speakers who we had at the last Tokyo workshop 3 years ago. First, keynote speech will be made by Mr. Thomas Novak, Secretary General, European Heat Pump Association. The title of his speech is "The Technologies for a CO2 Neutral Society Are Already Here, Heat Pumps." And the special lecture will be given by Professor Kiyoshi Saito at Waseda University under the title of "The Role of Heat Pump Toward Net Zero Emission." The Heat Pump and Thermal Storage Technology Center of Japan has been actively working on the penetration and also promotion based on the Tokyo Declaration and promotional activities in Asian region, where we expect huge increase of energy demand as well. So we started Asia Heat Pump and Thermal Storage Technology Committee since 2018. And especially in Vietnam, symposium and workshop were held. I believe that these activities will be presented today as well in today's workshop. The globe is in a serious condition for mankind. And abnormal climate condition is observed everywhere on the earth. And people are actually experiencing this. Melting ice in the North Pole and Siberian hydrate melting in tundra area. And what's more, dry areas in western part of the US, in Australia, large-scale wildfire broke out. And even now, in Texas, they are suffering from a large scale of power outage. In order for us to deal with this crisis, also international society decided to tackle this issue through the Paris Agreement concluded in 2015. So there was a strong determination confirmed that time. However, America decided to exit from this agreement, and there are lots of twists and turns. But now, under the new administration, President Biden decided to come back on board, which is really good news to all of us. Especially in the future, energy demand will grow significantly in Asia, for sure. So it's important for us to deal with this situation. Japanese government, based on the Paris Agreement, expressed their intention to contribute to decarbonization in Asian region, which is in line with the growth strategy. Until now, more than 120 countries all over the world declared they would make the greenhouse gas emission neutral by 2050. And Japanese government will follow this as well to make it zero substantially by 2050. And in order for us to realize this, what's most important is to achieve this goal is to improve energy efficiency, which is energy saving. And also at the same time, the core energy source in the future will be renewable energies such as solar power and wind power, for sure. So how can we properly utilize those variable energies is the challenge we face now. We do have solutions like storage battery and hydrogen, but we have to have a heat pump which has a high efficiency and less energy consumption, and a thermal storage system that can control demand and supply conditions. So I believe that these are the key technologies, including the standpoint of demand response as well, with no doubt. To fulfill this role, we need to overcome technical hurdles to further improve efficiency of heat pump and thermal storage system, which will increase its importance. Also, at the same time, we have to disseminate those technologies immediately. For this reason, activities conducted by Asia Heat Pump and Thermal Storage Technology are extremely important. I really hope that members will actively exchange information on policies in each country and technologies to accelerate those activities in each of those member countries for further promotion of heat pump and thermal technology. Japanese government as well set the target introduction units of heat pump introduction by 2030. EcoCute for residential, we achieved a cumulative shipment of 7 million units by June 2020. So that's what we achieved, and it's growing steadily. And on the other hand, so industry and commercial heat pumps, where we have a big potential, so we need to further accelerate promotion of those heat pumps as well. So in order for us to do so, industry, academia, and the governments are working together for product development, dissemination, and develop policies to achieve them, and also conduct promotional activities to improve awareness. And we need to clarify the position of heat pump and thermal storage system in all energy systems. Last but not least, stable zero emission energy ratio in all power source mix, and also introduction situation in the infrastructure, both cooling and heating supply network, where heat can be transferred to where it's needed, and also the status of decarbonization is different from country to country. So in order for policies and path forward to achieve decarbonization is also different depending on the country. So in today's workshop, not only sharing the status of each country, but also active discussion on effective utilization of heat pump and thermal storage system for decarbonized society in the future. So that I really hope this workshop will make a huge contribution to realize decarbonized society in the future. So here I'd like to conclude my speech as a chair. Well, thank you very much for your attention. So from here, I'd like to move on to the presentations. So first, I'd like to introduce Thomas Novak, Secretary General, European Heat Pump Association. And he's going to join our workshop early in the morning in Germany.
おはようございます。トーマスさん、それではトーマスさんお願いいたします。トーマス、始めるべきですか？はい、そうです。お願いします。はい、わかりました。ではちょっとスクリーンのシェアをさせていただきますね。
So, do you see my screen well now? The starting slide?
Yeah,
yes,
good.
Very good. Okay.
Perfect.
Well then, it's 6 o'clock in the morning where I am. It's afternoon where you are. So good morning or hello, heat pump world, I'd like to say. It's a great pleasure for me to speak here. And I must have done at least a little bit right, so that you have invited me for the second time after the great experience in 2017. Thank you to HPTCY for inviting and for Koki Watanabe for organizing all of this. I would like to use the time that I've been given to exchange some thoughts with you. It was mentioned now that the network, the HPCTY, the Asian Heat Pump Network, is for an exchange of information and consideration, and maybe it is something new that I have been putting together. So heat pump technologies are there. Heat pump technologies are, in my opinion, and I guess in all of our opinions, the most efficient solution for decarbonizing our societies. And just one word to EHPA. We are a network of 140 members in Europe, where heat pumps are now fully recognized. And you can see here on the map that manufacturers, labs and component manufacturers and researchers are united across the continent. We have one vision. We want to make heat pumps the key technology for heating and cooling in Europe for residential, commercial, and industrial application, and that includes district heating. So what I'm told when I'm working outside with the policymakers and other stakeholders, that heat pumps, heat decarbonization is very, very difficult. So it's a huge problem. And normally, when I'm told that, I'm reminded of something like the Apollo program. You want to put a man on the moon. That's a huge problem. So what do you do for that? You dedicate resources, huge amounts of money, the most skillful people to develop a solution that ideally is using less energy. So you want to decarbonize. It's also using less CO2. It should be based on renewables. It should be beneficial to the electric grid. From our perspective, it should be manufactured in Europe, so you replace that for your own region. It should be manufactured locally, we can say, because we want the employment. It should be easy to install. It should be available for all applications, and then it should be applicable across the world. And what I took as a photo here is a fusion reactor. That's one of these things where billions of euros, dollars, yen are spent to create a solution that should provide limitless energy. And now I stole from Apple, because Apple showed the Apple Watch and showed what it could do. And I would say we have heat pumps already. So if I hear from somebody, heat decarbonization is a really hard problem, I would answer, but we have a solution. So you don't need to invest billions of euros to develop it. We need to deploy it, but that's a soft problem. It's not a hard problem. We know how to decarbonize the world, at least when it comes to heating. And what we can see here is that the heat pumps are already in many appliances. I would say the trend goes to heat pump number 4 or heat pump number 5 for individual households. You have them in dryers, in washing machines, in your electric car, in a fridge, and of course in a heat pump system. We increasingly often also see ventilation systems that have heat recovery units, so another small heat pumps in the airstream. But they have additional benefits. We also see now that if you put the heat pumps properly into the electric grid, if they have good controllers, then you have them also for stabilization of the grid. And then it becomes even more important in today's society that we look at health. And heat pumps contribute to indoor air quality. All these are things you all know, but these are things that I find remarkable how often I have to remind policymakers about these benefits when we are discussing about this so incredibly difficult problem. And we can say we have a solution that also has nice additional benefits. And last, it also provides employment. We have looked at the manufacturers that are inside the European Heat Pump Association, and we could look 103 manufacturing sites. It's a lot of small and medium-sized companies, and these small and medium-sized companies are the ones that typically provide more employment. And the factories, for a reason that I cannot explain to you, are most often in the most distant parts of the country. So you can nearly never fly there. You have to take a car, and then when you enter the forest, probably a heat pump factory is around the corner. And with all these benefits, at the same time, this graph that I'm showing here shows the development curve of heat pump rejection, as I have called it. And these are the 10 years of my work in that field. I started by people saying, well, this doesn't work at all. So it's a technical failure, this product. And now we went through all these motions that you can see here on this graph. It's not using renewables. It's not working in district heating. It's not working in renovation. Now technology has advanced. Now people say, oh, if we have too many heat pumps, then they will crush the electric grid. And you know that we don't want that. We can defute all these aspects, but there is still a lot of what I would say perceived rejection against the technology, despite if you have one, you don't want to change. If I ask my kids, do you want a different technology for heating? They say, what are you talking about? This is great. Luckily, also in Europe, this is recognized in the market, not only by policymakers. It's recognized in the market. In 2019, we had 13.2 million heat pumps installed. The numbers for 2020 are coming in now. I can say we are moving close to 15 million heat pumps in Europe, and the growth rate is quite impressive. We have 8 years of continuous growth. The last year, we all know how difficult that was, but still showed an increase of 5% for heat pump technologies across Europe. Here, I will not read this out, so don't be afraid, but these are all the benefits because people want numbers, and this is important for us to say, but we can prove to you that we are providing renewable energy, we are saving energy. Energy efficiency is a big trade of heat pumps. We are saving final energy, and that also automatically, because we reduce combustion, means better air quality. And then when it comes to grids, it's actually the contrary. Heat pumps are not crashing the grids. Heat pumps are making the grid more stable, and heat pumps are making the electric grid more renewable. You can see here that we have calculated about 3.2 terawatt hours of demand response potential for all the heat pumps installed in Europe. How do these numbers compare? Because it's always easy to drop numbers on you, and then you'd never know what does that mean in relation. So Europe's buildings, and the latest data I could find is for 2015, Europe's buildings used 2,625 terawatt hours of energy in the past. And I go back here, sorry to the translators, maybe that is a bit too fast, but I'm going back here, and we can see that we have 225 terawatt hours from heat pumps. So if we compare the two numbers, then we can say about 10% of all the energy demand in Europe from buildings is provided by heat pumps. At the same time, how fast is the change? Because we want to decarbonize fully. So it's nice to have 10%, but where are we going? And you can see on this graph that on the lower dotted line, that is the renewable energy share from heating technologies in the European Union from 2004 to 2018. And you can see that we are moving very close to 20% over these 14 years. So it's an increase of 10 percentage points. It's too slow. That's the message here. It's too slow to decarbonize the European building stock in time. And I would say, if I talk to you about your own national numbers, you probably have the same problem. So we need more action. And what's happening here? We have set, the European Union, the European Council, the Parliament has set new targets. We are, as you know, selecting heat pumps are contributing to renewable energy. So we have a renewable energy target to be reached by 2030 of 32%, an energy efficiency target of similarly 32.5%, and most important now and very brand new, a CO2 emission reduction target that was increased to 55%. And some people say even that is not enough. We need to go to 60% by 2030. And for us, it's very good because we can say you can afford, as a policymaker, these ambitious targets because you have technologies at your hands. Now, the policymakers, they have not only decided about these targets, they have also put huge amounts of money behind this. That's Ursula Leyen, the president of Europe at the moment, and she has announced the European Green Deal and has added 1 trillion euros that are put up for the next legislative period to be invested in making Europe's energy sector green. It consists of a number of laws, of course, so that's important. It needs to be backed. We have an EU strategy for system integration that is mainly for the connection of the heat and the electricity sector. We have a renovation wave communication that's for the building sector. So what do we do with the least performing buildings? And we have a huge array of legislation, 15 initiatives altogether on how to reduce CO2 emissions by 2030. Most important for us is the energy system integration strategy at the moment, because it concludes that by 2030, 40%, you see the red numbers here, 40% of all residential buildings should be heated by electricity, 65% of all commercial buildings, and then industry is not mentioned, but we think that about 10% of industry should also be provided with heat pump related heat. And these numbers here, 65 and 40%, if energy efficiency as a principle prevails, then it means that all these electrically heated buildings will be heated by heat pumps. And if we add the numbers, that means then we have between 49 and 59 million units that we need to see in the market installed. And that is factor 4 from today. So we need to increase the market by about 19% every year to achieve that target. This is Mr. Timmermans, and he will help us on the other side of the spectrum. He's responsible for the renovation wave program, and the renovation wave will have one of the main features that it has is to renovate the 35 million least performing buildings. So you could say the quarter of the building that is least performant today, where we would have said this is not very well useful for applicable for heat pump technology, they will be renovated first, which means they are all automatically heat pump ready. So good times. And then we also see new business models, new actors, new ideas. We have here, I took a slide that shows, that reported about Elon Musk that wanted to bring the HVAC system together with his power wall, together with the solar PV tiles, and together with the car into the home of the end user. It will be a comfortable electric home that we can live in. And you can imagine if it's not offered by 3 or 4 different parties, but if it's offered by one, and admittedly quite attractive brand, which is Tesla in this case, then there will be also higher market penetration. And I would assume that also other entrepreneurs will jump on that train and will be using this idea of saying, we will offer you a joint solution for your building comfort. So all of this, we need 4 times as many heat pumps. And how do we do that? What's the way forward? That's some of my last slides here. So we think we need an adjustment of production of plus 15% every year. The industry says we are ready for that. But is the end user buying? That's the interesting part, because we want a market that is functioning. For this, we think the most important topics at the moment are no longer recognition, but now we need really hard facts that change the market conditions. And in many countries, that means electricity taxation versus fossil fuel taxation. How does that look? It has to be favorable for the energy carrier that is the cleanest, and that is typically electricity. For that, we need a CO2 price signal, and for sure, we need to stop fossil fuel subsidies. In order to activate end user demand, all these things will make heat pumps more economical, but we also need single-stop shoppings, one-stop shopping solutions that give advice to end users for the installation. From us, we have also provided some background information from the heat pump side to talk about heat pumps work in renovation and heat pumps work in industry. You can see two of our brochures here. And of course, under COVID, it's very important to connect these recovery payments that are paid to a green recovery. So if money is taken from the public, then it should be used for a green recovery that includes the renovation of buildings with heat pump technology. If all this happens, I see a great future. I think these 15%, maybe even more, is possible. And we are working together, hopefully, to make it real also across the world. I'm available for information. I'm really appreciating this exchange in this network, and I wish you a great conference. Thank you very much. Arigato. And with this, I give it back to the in Tokyo.
Thank you for your presentation, Thomas. Thomas-san, ありがとうございました。
Well, Thomas-san, thank you very much for your wonderful presentation. Well, from here, we'd like to move on to the presentations from each country in AHPNW. So 3 years ago, we held a Tokyo workshop, and we adopted Tokyo Declaration, joint declaration. And also, we'll hear some stories from Mr. Sasaki, HPTCJ.
です。よろしくお願いいたします。
Nice to meet you. So without any further ado, I would like to review briefly the Tokyo Declaration that we adopted 3 years ago in 2017. There were major 2 points in the Tokyo Declaration of the 2017. The first point is to work on the penetration of the heat pumps that were not penetrated enough. And the other key point is to encourage the government of each country to define aerothermal, geothermal, and hydrothermal energy heat pumps use as renewable energies. Renewable energies were defined legally more than 10 years ago at the EU committee under the so-called EU RES directive. In this legislation, geothermal energy, aerothermal energy, hydrothermal energy were defined as renewable energy along with wind and solar energies. It also sets a formula to calculate the renewable energy introduced volume, and each EU member country sets a renewable energy introduction volume target, and the targets of renewable energy volume captured by heat pumps are managed. I would like to explain how Japan defined the renewable energies from now. Japan defined what the renewable energy sources are and the non-fossil energies are under the law concerning sophisticated method of the energy supply structure in 2009. Thus defined the aerothermal, geothermal, hydrothermal energies as well as the solar and wind energy as renewable energy sources. So using heat pump to cool and heat or to supply the hot water means using a renewable energy source. However, Japan has not set the target of the heat pump installations to use renewable energy sources yet, unlike EU countries. Next, let me introduce the Japanese government policy goals towards the decarbonized society. In 2015, the long-term energy demand and the supply the outlook formulated in 2019 set the goal to reduce energy consumption by 15.3 million kiloliter of oil equivalent by the 2030, and the goal was to cut the green energy gas by the 26% compared to the 2018, which has been aligned to the large long-term energy demand and supply outlook. And in addition, the global warming prevention plan formulated in 2016 specified the long-term goal of the greenhouse gas reduction of the 80% by the 2050. And in 2019, the long-term strategy under the Paris Agreement was made. In October of the 2020, Prime Minister Suga declared the net zero of greenhouse gas emission by 2050 in his general policy speech. Let me introduce Japan's top runner program and the energy saving label. So that there are three the standards. The first is the minimum standards to achieve to clear the minimum standard. The second is the average the standards the method to clear the average value, and the third is the top runner system to mandate all the equipment to clear the best the efficiency when the standards is made. In Japan, the top runner under the top runner system in 1999, 11 items, including automobile household electric appliances, were subject to this system. However, currently the 32 items are subject to, and all the manufacturers to encourage to meet this goal. In order to achieve the top runner the system and to promote the penetration of the high efficiency equipment, we need to share the information with the consumers. And so under the revised energy conservation law enacted in 2006, labeling system was adopted. The last November, this system was revised, and the five-star system was changed from the simple five-step evaluation to the 41-step evaluation.
This chart describes the efficiency of trend of the heat pump. Since the introduction of top runner system, efficiency of various heat pump equipment has been improving every year. Next, I'd like to talk about the shipment volume of the heat pump in Japan. The energy mix I mentioned on the earlier slide, different sectors such as industrial, commercial, residential, transportation will accumulate outcome of these energy saving measures. They set the target of 50.3 million kiloliter energy saving. Part of the specific measures for energy saving talks about the introduction of heat pump, and goals are set. Industrial heat pump in industrial sector, commercial heat pump and water heater in commercial sector, residential heat pump and water heater in the residential sector are included in this initiative. Actual introduction progress and status of heat pump versus the plan is checked at the subcommittee of the government every year. What you see on the screen is the information we prepared based on the information, and the target for the residential heat pump water heater is 7.2 million in 2020 and 14 million in 2030. And as of 2018, it was 3.395 million, and versus the 2030 target progress ratio is 22.2. The target for commercial heat pump water heater is 50,000 in 2020 and 140,000 in 2030. As of 2018, actual shipment was 44,000 versus the target in 2030. The progress ratio is 13.5. The target for industrial is not the unit volume, but the capacity of the facility, 277 megawatt in 2020 and 1,673 megawatt in 2030. And as of 2080, it was 137.9 megawatt versus the target in 2030. Progress ratio is just 7.6%. So as you see, the progress for industrial heat pump is quite slow. For the introduction of industrial heat pump, you need to have an expertise such as the characteristics of the heat pump, heat mechanism of the manufacturing process in the plant and the heat volume as well, and those are different from one plant to another. So it won't be a general packaged product for the one we have for the residential application, which is a big challenge. Also, we need to simplify the study process. General simulation tool has to be developed. Also now, the shipment volume for the industrial heat pump is low. The price tends to be high. We can expect lower price by doubling shipment volume, but to realize this good cycle, it's important to offer financial support. So on the earlier graph, that was the actual volume based on the information 2018, but this on the slide, this is accumulated shipment volume of residential heat pump water heater. It's been 20 years since it was launched in 2001 in June, exceeded 7 million and 7.3 million in December, and hit for the full year target in 2020. So versus the price wise, it's really high, but because of the financial support, we see the steady progress of the shipment, and the price has been falling. So financial support was a big trigger. Well, from here, I'd like to talk about the future of Japan. And 4 months ago, in October, Prime Minister Suga declared carbon neutral in 2050 to achieve decarbonized society. Based on this, in December, they developed a green growth strategy in line with a 2050 carbon neutral. This strategy is considered as an industrial strategy where a challenge of 2050 carbon neutral will be triggered for realizing good cycle of economy and environment. For 14 areas, ambitious goals are set describing current issues and future measures including budget, tax reform or regulations, and standardization and collaboration with international society. And they are inclusive in the execution plan in place, especially in power sector. Decarbonization is a baseline, and other than power sector, electrification is a core activity. For electrification of the heat in the future, heat pump will play a main role. However, in the industrial sector, there's a lot more to do to further expand the penetrate and industrial heat pump. Financing and simplification of study process are important, which I mentioned earlier. From finance standpoint, in the extra budget for this fiscal year, announcement was made on the subsidy to support introduction of heat pump mainly for industrial heat pump. 4.65 billion yen was allocated to it. We expect that a lower price by increased shipment and good cycle is generated as a result of this, which can be achieved by more penetration of industrial heat pump. As for the simplification of study process, Professor Saito at Waseda University is working on the generalized introduction study simulation tool that can be applied to various use cases. I believe Professor Saito will present it to you at the special lecture. Well, this is the end of my presentation describing the current situation and the future. Heat pump and the thermal storage center of Japan will function as a national center for heat pump and thermal system in Japan. I'd like to make more contribution to the penetration of heat pump. Well, thank you very much. Next, I'd like to introduce our presenters from Thailand. So Spachai-san, Department of Alternative Energy, Development of Efficiency, and Pierre Chida, Associate Professor, and King Mongkok University of Technology.
Hi, Spachai.
Hi, Koki.
Hi. Good afternoon. Now, floor is yours. Go ahead.
Oh, okay, thank you. Thank you, Koki. Can I start now?
So can you share your presentation material?
Uh, is it all right?
Oh, can you make it much bigger? Yes.
It's not full screen yet.
Okay, Spacha, it's okay. Go ahead.
Sorry, can you see my presentation?
Yes.
Yes, yes, you can see it.
Okay, thank you so much. Good afternoon, everyone. In this seminar for ASEAN heat pump and thermal storage technology network. In this short time, around 15 minutes, I and Dr. Piyatida from Thailand will talk with you on about heat pump market trend and policy support in Thailand. In the Ministry of Energy of Thailand, there are the target in the administrative and the strategy with Thailand integrated energy blueprint. Within the power development plan, energy efficiency plan, alternative energy development plan, gas plan, and oil plan. Uh, in this time, I would like to focus only about the detail for EEP plan. In terms of EEP, the target need to reduce energy intensity around 30%. With the base year 2037, and the base year from 2010. In the final energy consumption in Thailand in the 2019, the total final energy around 85,829 KTOE. That consists of came from transportation, industrial, residential, commercial, and agricultural. The for nowadays, the energy efficiency plan from 2018 to 2037. In the long term, for reduction target by the main strategy and five sector consists of compulsory, voluntary, and complementary. And five sector consists of industry, building, household, and agriculture and transportation. And 4D and 1E policy consists of digitalization, decentralization, decarbonization, deregulation, and electrification. In the standard labeling program structure may be different from another country because the framework run by two ministries. It consists of Ministry of Energy and Ministry of Industry. The HELPS program conducted by MOE and the MEPS program conducted by MOI. And to Thai's labeling number 5 label for the household and for the industrial. This slide may be a lot of detail in the step of to define the law and regulation for maps and HEP in Thailand. The criteria, we give only 20% to pass the HEP level in the market. The policy and implementation of heat pump in Thailand. This is the existing program within the energy saving number 5 label. The label, this label for only low temperature and small scale. In addition, we have a subsidy program around 20% and 30% to subsidy program of labeling and another equipment. And another, we have a building energy code to use the heat pump in the program. And the last one, testing laboratory. We support the budget to the laboratory to develop the testing room for heat pump in last year. Furthermore, in Thailand, we have the collaboration with the Japan government and Thailand government to to promote the heat recovery heat pump via the seminar and another activity. And additional, we have the collaboration between Thai government and Japan government to support the clean energy technology. And we have an example activity in Japan. We have already on-site testing to verify the COP for heat recovery heat pump in Japan. In Hiroshima City, this led by METI and JICA, and collaboration with the private sector in the region to promote EE heat pump. We have the collaboration from 4 government agencies from Thailand, consist of the EDE, the IW, TC, and King Mongkut of Thailand. This is thank you information from the private sector in Japan. Within the subsidy by JCM, we have the pilot project to install the heat recovery heat pump in CPF company in Korat province in Thailand with 8 unit recovery heat pump. In addition, we interest to study renewable energy portion by the SDG business models formulation survey with the private sector for energy saving cooling system using underground heat source in Thailand, and case study in Japan supported by JICA. And so many cases in Japan need to use the thermal site, for example, in the school, in the swimming pool, in the on the roads, of the city, and another one. But different from Thailand, Thailand need only to use cooling site more than the thermal site for GSHP heat pump. And this slide, I would like to describe the history of TTOP underground project and the beginning GSP installation heat pump in Thailand. And information from research to find value of subsurface pressure in each soil level. several places of the Lower Chao Phraya Plain in Thailand. In this slide, in the last one, nowadays the Department of Mineral Resources going to approve the proposal of GSP system installed to the Geological Museum at the Pathum Thani province in Thailand. And finally, I was attend the ASEAN meeting on 2 and 3 February in this year was hosted by DEDE. I think that the CFIA program from METI may be useful for us. There are the financing program to promote low carbon and clean energy technology for private sector, such as heat pump technology and the other technology in this region. Thank you for my information, and next slide continue with Dr. Piyatida from Thailand.
Okay. Thank you, Dr. Suprashai. Could you please stop your share? Okay. Hi, good afternoon, everyone. My name is Piyatida from King Mongkut University of Technology, Thonburi. And today I will present about the market trend of the heat pump in Thailand, and also some, testing standard that conducts in Thailand. And as Dr. Supachai say about we have a setting for the MEP and HEF for many products in Thailand. But for the heat pumps, we have the criteria for the HEP and MEP for just only for air to water heat pumps. And right now, the testing lab in King Mongkut University of Technology, Thonburi, we can conduct just only the capacity lower than 36 kilowatt. And for the standard testing, we perform the testing based on the procedure of EN 255-3, but the condition, the testing condition will be adopted for Thailand weather condition. And this laboratory, we get the certification on the ISO 17025. And right now, the DEDE has been promoted for the energy efficiency labels. As you see, there are some the criteria to get this label that I will be present later. And to determine for the MEP and HEF for the heat pump that's sold in Thailand, we conduct some the study in 2013, and that time we sampling the testing product from the real market about the 13 set of the heat pump and test with the under Thai condition, and we get this data. And at that data, we determine for the MEP at the 2.4 of the COP tapping, and for the HEF, we determine the COP tapping should be more than 3.0. And at that time, we found that more than 50% of the product, about the 7 heat pump, has been passed for the HEP programs. And therefore, for the to make the criteria for the MEP and HEP standard, we use that data for this one. And for the MEP, that's the COP tapping should be more than 2.4. This is a mandatory program that certifies by the TC. TC is a Thai industrial standard institute, but unfortunately, this program is, the draft of the standard is still in progress, is not announced yet. And for the HEP that conducts by the DEDE, this is a voluntary program. The COP of the heat pump should be more than 3.0. If the product has a COP tapping more than 3.0, they will get the energy labels here. And, oh, sorry. And for about the testing procedure, we follow the EN 2.5-T and using the Thailand weather condition. The condition is a dye-bound temperature. We test at the 35 degrees Celsius and wet bound at 24 degrees Celsius. And the COP can be calculated just only from the tapping process, not in the heating process, same like another country. This is maybe can result on the lower COP as compared to another products. And this is a schematic diagram of the testing room that have control for the temperature, humidity, and by using the chiller and the heater and humidifier. Oh, sorry. And this is the results compare between the COP testing results in Thailand at 2013 compared to another country. You can see that there are some product is the lower COP than another because we concern the COP during the tapping process, not in the heating process as some standard in another country. And this is the information in 2012 that the market share of the heat pump in Thailand is mainly in the hotel sector and a little bit portion in the industrial sector. And this is the number of the heat pumps sold in Thailand during 2008 until 2019 is the trend is look like increase year by year. And this is the results on the testing. In 2019, they found that there are many heat pumps had been tested in KMUTT to get the energy saving level, and most of the popular size is about 13 to 19 kilowatt. And this is the COP tapping for the product about 900 products of the heat pump. You can see that most of them, the average of COP is to be 3.4. And this is a table to compare, the products that test by KMUTT during 2016 until 2019. You can see that the average COP has been increased year by year. And also, the number of the percent part, to get the energy saving level is increased until 2019 is success almost 100%. And for the current situation in Thailand, it seems like the heat pump market is still limited in just some sector, especially for the tourist sector. But by the way, there right now is was disrupted by the COVID-19 pandemics. So the effect on the slowdown on the investment of the tourist industry, and also the expansion of the heat pump market in other application is still limited. Therefore, they need to the promoting and introducing the heat pump technology in various applications such as the heat pump dryer and also the high temperature heat pump. And for the last one, the problem of the heat pumps in Thailand is as I told you that the mandatory program is not enforced yet by TC. So right now there are some products from other countries that the price is quite very low, is coming in the Thailand market because the consumer is decide to buy the product with the capacity, not with the price, not decided by the capacity and its performance. That is all for my presentation. Thank you very much.
Okay, thank you for your presentation, Spachai and Piachida-san.
So now that we would like to have some time for Q&A, but originally we were supposed to have a Q&A session. However, this presentation used up all the time we scheduled. So we would like to skip the Q&A section for Thailand presentation. But thank you very much, Spachai-san, Piachida-san. So next, I would like to invite the presenter from South Korea. And Mr. Jun from the South Korea testing laboratory. Jun-san, it's your turn.
I'd like to share my presentation. Give me a second, please. Yeah. Okay, where's the... Actually, I have the two monitor, so yes. So, can you see that?
Yes, we can see it.
Okay, so I'd like to change the switch then on my screen. Where's the screen changing? Okay, so. Yes. Oh, yeah. It's fine?
Yes.
Can you see the clear?
Yes.
Okay, thank you. Thank you so much. Okay. Okay, so thank you. I'm Jun Choi, and who is work for Korea Testing Laboratory. And I'm also a representative of the AHPNW network. Last is almost 10 years. And I'm also currently in charge of the vice president of the SAREC, a society of our academic society. So actually, country is. I believe all of you are very well as usual under COVID-19. So since the last years that all globally we are all very deeply, is a big damage on pandemic. Is nowadays a lot of the meeting is online meeting. I think that everyone is this kind of the meeting is one of part of your life there. So and then I really appreciated the HPCTJ their support to arrange this kind of the meeting. As you know, there is quite a big job. Okay, so let me go back my title. Today I'd like to deliver is my topic, the heat pump trend and forecast, the market and energy policy in Korea. I believe that my presentation could help you to understanding and our condition, our situation of our South Korea. Okay, now move to the next one. So, okay, this is our energy balance pro. The first of all, I'd like to introduce is how is the energy balance of South Korea, Republic of Korea. Yeah. This data is coming from the 2018. Unfortunately, it's not available to get officially 2019 or 2020. So I have to analyze it only the 2018 data. Well, as you look at that, so in Korea, we are a very regular energy natural resource. Almost is 94% energy coming from overseas. In 2018, we spent 140 billion US dollar. It's quite a big money. Actually, it's imported of the natural resource is quite a big burden on our economy, but it's quite depends on the price on a natural resource. Well, okay, so mostly the crude oil is number one. Is crude oil mostly we are imported from the Middle East. 74% crude oil come from Middle East, and some of the others is from Asia and Africa. And also the LNG and the vitamins, the nuclear, is anticarcide, is also we have to import it from the overseas. So, and the 2018, the domestic production also we have the 6.3% from the all imported production. So well, it's quite a small amount of the compared to the all natural resource imported. Well, so now look at the primary energy. Is in 2018 we spent 307.5 million TOE in a year. So 38.5% is crude oil. The next is bituminous energy, 26.6%. And then the LNG in natural gas is 18%. And the nuclear is 9.2%. And the graphite 1.6%. And the renewable and the hydro together is 6.1%. This is our primary energy condition. So, and transformation loss. So, as you know well that, okay, so when you converted the primary energy to the final consumption, you have to transform the energy from its original energy to the final energy. So, where almost 24.3% is number the 74.8 million TOE are lost, transformation loss there. So, well, how is it the electric power? So we produce the 570 billion kilowatt hour totally in a year. So as you look at that, okay, so nuclear is the 23.4%, is a bituminous 42.3%, and LNG 26.8%. So look at it, the last one, renewable, 5.6% of all electric production. It's still quite a small, amount comparatively. So now how is the final consumption? So okay, it's a little bit different situation to other European and the US. So industry energy consumption dominantly 61.4%, about quite a big energy consumption. So residential and commercial at 17.8%, and transportation 18.5%, and the public 2.4%. So normally it's the other developed country. So where industry and then residential and the transportation normally very similar energy final consumption, but in Korea we still have a very big energy consumption of the industry. So this is our energy balance. It's energy outlook. So currently. So okay, how is the market profile? So actually, this is in a heat pump, network. It's everybody wanted to know though. It's a market profile of a heat pump. Actually, this graph and this table is our analyzed the last 3 years, from 2017 and 2019. Actually, this data come from KRAIA, our Korea Association. Well, normally, and the heat pump, as air conditioner is including heat pump being sold in Korea, they apply it to the RAC and the PAC. RS means the room air conditioner, and the PAC is a packaged air conditioner. So as air-to-air type, it's the mostly applied air source. It's a domestic, is the market by dominantly of the air source. Is a current recently in the other in the source is the geothermal and the water source. Water source in the aqua is the hydrothermal. Heat pump also is coming to the market, but the air source heat pump is quite dominant market. So look at the air conditioner is profile market profile. Okay, so 2019. So okay, so room air conditioner is 1,000,007 something, and then so about 15% of total RAC is heat pump, and also the PAC packaged air conditioning. So can you hear me? Okay, sorry. Okay, so packaged air conditioner PAC is it was sold at 1.9 million something, and then among them almost 20% is a heat pump system, also included VRF. So it's still total air conditioning market, but the heat pump market about the 15 or 20% to the air conditioning market. So, and this data is on the residential and the commercial, is not including the industrial because it's not available to get the industrial data market. So this is our the current market profile. So, okay, I think that is quite interesting stuff. Okay, well, in the Japan and also the Thailand, they are mentioned in the heat pump water heater, also heat pump water heater. Well, actually, in Korea also, this market has been started since 2013, almost 8 years ago. Because that actually, this kind of product, well, it's expected to expand in the residential area with the KEPCO, is a power company. The KEPCO, they implemented a new program to support this kind of product, heat pump water heater, because that the existing resistance heating boiler, it has been already installed the 550 units, 1,000 units in nationally last 25 years. And so KEPCO, they wanted to replace this kind of heat pump for a heater with the existing heating boiler system. So their KEPCO, they started the new support program. So okay, this data from 2014 to 2018. So actually, this is installation by capacity. Normally, all in the stage, so kind of small size capacity mainly, and but recently more larger capacity is a 13 and the 14, the 15 capacity heat pump water heater was sold in our market. And the installation by the region, actually the in Korea we have actually the standard they provide the three kind of the climate zone. It's a warm and cold, moderate. And so in the KEPCO, they adapted our standard to penetrate this kind of product. So, and as I noted from last year, a totally 50,000 something, over the 50,000 unit are sold in Korean market. Okay, but it's one of a big barrier to expand this kind of heat pump water heater. This is the price. It's compared to the other existing boiler system. It's that this is kind of a heat pump water heater is very expensive. This is kind of big barrier to penetrate, expand it to Korean market. So okay, now move to your regulation. Well, So actually, in the heat pump market, heat pump industry is very, very deeply related to our law and regulation. So in the general, we have the two energy law. One is the Energy Act. Second is the Frame Act on Low Carbon and Green Growth. These two law are major prior law to be defined our heat pump industry. Okay, the Energy Act was established in 2006, and then current we have the 2019 version. The general contents, something like that. This law aim at the blah 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 is by the general, and also and the Framework Act on Low Carbon and Green Growth. It was established in 2010, and regularly they revise it, and the current version is 2019.
Johnson,
Yep.
you have another few minutes.
Okay, sorry about it. Okay, so I a little bit hurry up there. Sorry about it. So okay, and so energy policy we have the two one. One is the improvement, one is the alternative energy. Actually, the heat pump industry very very strongly involved in this. I'm sorry about it. Okay, a little bit quickly. Okay. This is okay. Under the main law, we have some the regulation. Is one is part of the energy saving, and the one is the renewable energy. So could you refer for me? Okay, this is energy labeling and energy efficiency labeling standard program in Korea. Probably this information was introduced by me at the last Tokyo meeting. So, where actually the electric heat pump, the BRF, the two items are included in this program. Okay, so subsidy program. I'm already mentioned that this program supported by the CAPCO. CAPCO provide the benefits for an installer of a thermal storage system and a heat pump water heater. Actually, they have the two programs. One is the subsidy for thermal storage appliance, and the other is a heat pump water heater. Actually, heat pump water heater, as I mentioned, that is a program has been launched since 2013. It's now almost the 8 years there. So this is a subsidy program. Okay. So, well, okay, this is a renewable energy. So everyone that's okay. So very very interested in the renewable energy. So as far as the geothermal heat pump has been recognized as a renewable energy equipment since 2004 in Korean market, but market is quite limited, as you know well. So recently, enforcement of the decree under the Act has been devised to add the water source, water energy, to in the 2015 and 2019. In 2015, we defined the surface of the seawater, and then 2019, you also added the river water. So, but we are still, and the river water and the source, we are still discuss that because the definition and the scope is not clear. So, and the geothermal market quite even very limited, but water source market, they have a very big potential because it's very easy to use the water source in every buildings there. And but we are still discussing in the definition and our usage there. Okay, so look at it. This is one of the landmark building at the Lotte Tower. At the Lotte Tower, they are using a water source heat pump system. Okay, this is a general energy building. Everybody know that it's a very, very hard issue to expand the general energy building in global. In Korea also. Actually, that from 2020, the general energy building is one of a mandatory program for a specified building. And so actually, in order to achieve a general energy building, the heat pump system is one of the key technology. So, and actually in 2000, by the 2003, in the public and the private building, about 500 square meter, they should be certified by specified zero energy building program. So it's a lot of zero energy building. They have to adapt to the new renewable energy equipment. So I strongly believe the heat pump system is one of the key players to achieve the zero energy building. So, okay, it's a closing. So, well, I'm already mentioned the energy outlook of the Republic of Korea. So obviously depends on the almost of 94%. But so on the renewable energy, so electric production from renewable energy only 5.6%. But our government, they announced that this percentage will be 26% by 2036. Next, 25, next 15 years, this is renewable energy electric production. It should be increased there. Okay, market. I mentioned already a couple of times. The current market of heat pump is quite small compared to cooling only, but we expect its market will be bigger than existing boiler market in commercial and industrial next 10 years. The main product in the PHC, in the VRF, the heat pump water heater, and then so there's some other in the heat pump system. And the role and regulation. So energy saving and the renewable law regulation, they are very, very deeply involved in the heat pump market. So how to expand our heat pump market? So one of that encourage air source heat pump to add it as renewable energy equipment. So unfortunately, we just recognize that. So accepted only in the geothermal and the water source, but not air source heat pump. But our industry stakeholder people, they try to get this aim. And they evaluated any of the environmental impact for heat pump usage and expand. And also, we needed to fully support from an MOTI and CAMCO, the government and the government-related organization, the strategy on the DSM. And also, so we have to increase the zero energy building to expand in the nationwide. Okay, this is my presentation. I'm sorry about that. I have a lot of only the 2 minutes though. Okay, this is my presentation. Thank you. Arigato.
Jun-san.
Yep.
Thank you for your presentation. では、ここでですね、質問をですね、
So we'd like to receive some questions, if any. Those who have some questions, please use the hand raise button to let us know.
Are
there some people who have some questions?
はい、Jun-san、ありがとうございます。
Okay, Jun-san, thank you very much. It seems that there are no questions about your presentation. So I'd like to move on to the next presentation.
では続きまして中国からのプレゼンテーターをご紹介いたします。中国建築科学研究院のヤン教授です。ヤンさん、よろしくお願いいたします。
Hello, everyone. I'm Yang Lian. I am Yang Lian from China Academy of Building Research. It's my honor to have this opportunity to communicate with the heat pump experts. Now, I will introduce the policy and the market of heat pump in China. My introduction includes 5 aspects. The first part is the energy and building. The total energy consumption and composition of China is developing very fast. You can see this figure. Coal still accounts for a significant proportion of all the energy consumption. Coal remains to be China's most used method to generate electricity. But in recent years, the proportion of solar and wind power generation is rising, and China is trying to adjust the energy structure. This slide shows the trend of China's building construction. The annual construction areas is gradually decreasing, but the cumulative construction areas is still increasing, and the building energy consumption continues to rise very fast. In 2017, China's total building power consumption reached 1,500 billion kilowatt hours. The data have not been updated, but we know the trend in the past 3 years is also rising. Okay. Okay. So we can see from above, China's total energy demand and the building energy consumption are still rising, and the energy conservation and the emission reduction are facing serious challenges. To reduce the high energy consumption and high air pollution, the Chinese government had issued a serious energy saving policy. You can see as this slide, such as by 2030, the carbon intensity per unit of GDP will fall by 6% or 65% compared with the 2005. China also will control and reduce carbon emissions through market trade. Chinese government also committed to reform its energy structure. Clean energy and renewable energy are getting more and more attention. From this picture, you can see it can be seen that China plans to reduce coal consumption by half by 2015, accounting for 40% of the total social energy consumption. The proportion of other clean energy source will increase significantly to make the energy demand. So the government is building a system of energy conservation and environmental protection. We will do the work from the following 6 aspects. Promote the harmony between man and nature, sub-regions construction function, promote the development of low carbon circle, comprehensive and efficient use the resource, increase the environment governor, and ensure the ecological security. From the above, we conclude that China's priority policy are as following, like the left. And we know the advantage of heat pump. In response to a serious environmental protection needs of the Chinese government, heat pump technology has become an important support for achieving these goals because it's high efficiency and it's clean and it can use renewable energy. So heat pump got great policy support in China. This is the policy about air source heat pump. Some provinces, such as Beijing, Tianjin, and other cities, has issued subsidies policies for air source heat pump. Take an example, Beijing will give 24,000 yuan per household. And the other city also gave some subsidies for the household use the air source heat pump. With this implementation, Chinese government give some money to the users, so the total sales number will grow very fast. This is for the air source heat pump market of China. The household heating accounts for about 92% in 2017. Frequent consumption units are becoming the mainstream. Commercial air source heat pump are broad proposed. It may be accepted research reach 1.245 million units by 2020. Okay, so this is a little delay. This is
こちらの方で示しておりますのがヒートポンプの送水。
okay. After more than 20 years of development, ground source heat pump has been widely used in China. At the end of 2019, the application area of ground source heat pump was over 500 million square meters. China is the country with the largest accumulated application areas of ground source heat pump in the world. But from this full picture, we can see the development of ground source heat pump in China has had declined since its peak in 2013. The development of ground source heat pump in China can be divided into 4 stages, maybe the start stage, spread stage, and the rapid stage. Now, in the stable stage, the development is paying more attention to the suitability and economic of ground source heat pump. The application of ground source heat pump enters steady stage, which under the combination action of push caused by the demand and the resistance caused by the technical bottlenecks. But there is some new opportunity of ground source heat pump. As I introduced in the former slides, the area of ground source heat pump used in farmer house in Beijing reached 1.42 million square meters by the end of 2018. Ground source heat pump become a new main technology of rural clean energy transformation. The 4th part is R&D strategies. Some national R&D plan was issued. One project of CABR, our company, is focused on the developing high energy efficiency heat pump products and the technologies which used in near zero energy consumption building. Another project studies solar energy heating in Tibet, air source heat pump heating in Sichuan and Tibet, and evaporative cooling technology in hot and dry western regions. This plan is also was charged by CABR. Shanghai Jiao Tong University's project aims to develop compressive high-efficiency heat pump for industry waste heat, high-efficiency absorption heat pump, and chemical heat pump for upgrading the grade of low-temperature heat energy. And the Chongqing University's project is to develop winter and summer shared heat pump products and high-efficiency cold and heat source equipment systems. So, clean heating, research of deep geothermal and heat pump technology, absorption heat pump technology, and the industry waste heat pump are the hot spots of R&D in China now. Research and develop the special low-temperature air source heat pump technology is very popular because of the need of clean heating in the North China. This is the 3-cylinder 2-stage compressor developed by Greek Electricity, which is the largest air conditioner manufacturer of China, which is suitable for the air source heat pump units in cold areas. medium deep geothermal heat pump technology is developing very fast in China. Now, the application areas was exceeded 10 million square meters, may used in Shanxi and Henan province. Most of these are coaxial. So on the left picture, the borehole depth is about 2,000 meters. We test some project and the heating, the COP of the system is better than the shallow geothermal heat pump system. Absorption ground source heat pump is popular because it can more suitable for cold regions and can effectively improve the imbalance rate of ground source heat pump in cold regions. Industrial waste heat pump systems are being used more and more. Even in the city scale projects, the waste heat can be used as the heat source or as both heat source or driving energy. So in general, the development of heat pump technology in China got good policy support by government, and the market application environment is very well. Due to the huge demand, China has become the largest heat pump producer and the largest application market in the world. And we have many good actual projects in use. Heat pump will play more and more important roles in heating and in domestic hot water application in future. That's all. Thanks for your attention.
Yan-san, thank you for your presentation. ではここで
Well, I'd like to open up the floor for question and answers. Those who have some questions, please use the hand raise button, the button on the screen. We'll welcome questions from presenters or speakers as well, if any. Are you okay? Okay. Seems that there is no questions. Let's move on to the next presentation.
では続きましてインドからのプレゼンテーターをご紹介いたします。
Next, I would like to invite the presenter from India. The Indian Society of Heating and Refrigerating and the Air Conditioning Engineers was supposed to send the Mr. Vijay. However, so that we would like to invite the Mr. Saravanan from the iShare, the organization that Mr. Vijay belongs to.
Are you okay? Now floor is yours, please.
Yeah. Can I go?
Yes.
Yes, we can hear you.
Okay. Thank you. So this is Professor Saravanan, currently the Vice President of East Trade. So I'm presenting on behalf of Mr. Vishal Kapoor. Unfortunately, he could not able to join today. And so his presentation topic is on heat pump status, forecast, Indian market potential. And so the presentation overview. First, we'll be introducing about the heat pump and what is the current trend in India. And we will be presenting a case study on the successful operation of heat pump and what is the heat potential in India, and concluding remarks. As you are aware that the heating is mostly for domestic, commercial and industrial application in India. India, we don't have any space heating requirement. and we have maximum heating requirement is only in the industries and in commercial buildings. So recently, most of the commercial water heat market has been increasing over the years due to the development of high-rise buildings, luxury hotels, hospitals, malls, airports. There's a tremendous growth in these sectors. Also, smart city projects. And people are looking for improvement in overall efficiency of this existing water heating equipment. Thereby, they can able to reduce their energy cost. If you look at the industrial heating only, almost 42% of all the energy consumed in India by the industrial process, heat alone, that includes temperature range over 250 So we consume about 15 million tons of fuels annually to generate this heat requirement for this industry. And the various temperature range from 60 to 250 degrees centigrade is requirement of process industry heat. So the energy heating constitutes about 10 to 30% of the total fuel requirement. At present, this industrial heating mainly made through fuel oil, coal or biomass or with the solar thermal heating. But due to pollution from these oil-fired boilers or coal-fired boilers, there is an interest to go for a conventional or renewable fuel type, which will have the energy efficiency as the key. So the heat pump is going to play a major role in India, only in the water heating segment, both in the residential, commercial, and industrial application. I could see the market potential growth is mainly on the commercial and industrial sectors. So the current trend is most of the heat pumps in India are air source and water source heat pumps, which is commonly used. For the residential capacity, we have a heat pump capacity up to 2.5 kilowatt, mainly a air source heat pump type. And when you compare it with other countries, we are just starting the heat pump market for residential application. The growth rate in this particular sector is very slow, mainly due to initial cost is very, very high compared to the conventional electrical geyser used in this application. But the commercial heat pump, if it is more than 15 kilowatt to 1000 kilowatt capacities, machines are now available in India. It's about water source type heat pump. We have around 5,000 unit has been installed and in operation. So in the commercial heat pump, mainly use it for maybe some application for space heating and for chilling applications, storage applications. Most of the application has been used this type of heat pumps. So the success of the heat pump still Indian industry or the commercial sectors are not aware in this in the last 3 or 4 years. Now only we have large number of success stories and advantage of this commercial heat pump water heater. Okay. So I'm going to just present a case study on the commercial heat pump water heat pump for a luxury hotel which has 200 rooms. The water requirement is about 20,000 liters per day. The peak requirement is about 4,000 liters per hour. So the hotel is connected with a sanitary hot water application, space heating and swimming. The temperature rises from 15 degrees to 55 degrees centigrade. About 40 degrees centigrade rise in the heat pump is envisaged. The heat energy required is about 930 kilowatts. This is a schematic flow diagram of heat pump in the industry. So you have a heat pump with a balancing tank and also with the end-use appliances. So they have a 3 set of heat pump unit for doing various these applications, which is connected to the common thermal storage system. which could be taken care for, depends upon the demand. The service is rented for the customer for 24-hour operation. So when you look at the cost of the fuel existing, they're using a diesel-fired boiler. The capacity is about 10,200 kilocalories per kg. The efficiency of boiler is 95%. Diesel required per day is about 52 kg, okay, or 109 liters. The cost of the fuel is about 90 liters Indian rupee per liter of diesel. Okay, so this cost is increased over the 1 year. From there is a tremendous increase in the cost of the diesel. Okay, so they are spending about 10,000 rupees per day. Per year, they spend about 36.5 lakhs of fuel cost to operate this water heating requirement. When it is replaced with a heat pump, F2RCS heat pump, which has been installed and it is successfully in operation, which has a COP of 3.5. The total power required is only about 266 kilowatt hour for the operation of the heat pump to deliver about 930 kilowatt of heat. So the cost of power per day is Indian rupees 2660 per year, per day, and the per year is about 10 lakhs. So the total saving per year is about 26.8 lakh Indian rupee. So we can able to save, or the payback period of the heat pump installation is less than 1.5 years in this typical installation. So from the history, we are promoting these type of case studies among the Indian consumers to switch over from inefficient diesel-fired boilers or electrical connecting heat, direct-fired electrical heaters to the heat pump technology in the years to come. So this will have other benefits also, as you can see. You have a reduction in greenhouse emissions because of going for this heat pump technology, and there is no risk of fire and explosions, and handling of the fuel is easy here, and it doesn't require a number of operators. It's very simple. You can connect with the building management systems. The same air conditioning technician is able to maintain and operate the heat pump systems without increase in your manpower cost. And the cold air discharge could be used for a cooling purpose. Okay, this is another advantage. The operator side, most of the hotels, they are integrated with the cold side of the equipment. So they are doing the air conditioning part of this using this rejected heat by reducing the cooling demand also in the industry. So there is a double advantage people are getting through this installation of heat pump in the commercial sector. And also we can go for these modular systems, multi-compressors, which offers redundancy. So the operating range, these heat pumps are suitable from -15 to +43 degrees centigrade, which is available in Indian market. But so most of the systems, now most of the companies are promoting the heat pump aggressively after seeing the success stories in most of these industries. So when you look at its application side, the residential applications, commercial, industrial application, this is the range of temperature range is required. As I told before, Indian industries require a temperature range from 60 to 250 degrees centigrade. So from 60 to 110 degrees centigrade, heat pump are used mainly in the automobile industries. Now the people are going for the automobile industries in the paint repair shop. They are using it, the heat pumps exclusively. And majority of the heat pumps in India is based on vapor compression heat pump. There are few vapor absorption heat pump which could operate in a hybrid mode for both for heating and cooling. Is deployed in some pharmaceutical industries, and but the insulation is very small. Okay, and Indian industry, Thermax is offering absorption heat pump, high temperature absorption heat pump for the various market. The capacity they are delivering is up to 100, up to 500 tier, 100 tier heating machines are available. Modular heat pump machines are available in India. And as I told you, the many installations only for hot water generation, since space heating is very, very limited. And nowadays there are few installations. They are using heat pump for drying applications, specifically for high-end value product, horticulture product. And recently there will be some few installation for heat pump for fish drying applications also. To sum up with this heat pump market potential, at present you have this available capacity of the systems is from 5 kilowatt to 1200 kilowatt. These systems can able to cater the hot water temperature from 60 to 80 degrees centigrade. But I explained to you before, there has been increase in urbanization, which leads to demand of smart city buildings. And most of the green buildings, in order to have high energy efficiency ratio and reduction in operational cost, most of the high-rise building and green buildings, they are adopting heat pump technology in the commercial building sectors. And our national building code, which is also promoting heat pump for water heating applications, and our ECBC Energy Conservation and Building Code 2017, which is also promoting water heating through the heat pump and also by solar heating. And India renewable energy industry or ministry has identified 100% depreciation for heat pump products, and other interest depreciation benefits are offered for the heat pump systems. And up to 10 kilowatt segment is expected the largest heat pump market by rating capacity in India. For higher capacities, mostly industrial customers are looking for. And in my opinion, all this industry is looking for a high temperature heat pump in the range of 100 to 150 degrees centigrade, which has a great market potential is available. So if any industry is having a heat pump which could deliver consistently at a temperature over 120 to 150 degrees centigrade, there is a huge market potential is there in India, in the Indian industries, mostly for process heat applications. So as per the forecast by the independent agency, Indian heat pump market is going to grow from 54.3 billion in 2018 to 94.42 billion in another 2 years' time. And our CAGR rate is about 11.68% during this forecast period. So the future is great for heat pump in India, especially for high temperature heat pumps and industrial heat pumps, and also in the commercial sector. Okay? So the market potential is there, but for the residential heat pump, initial cost and the cost of the initial cost of the heat pump is a major factor to grow in the residential sector. Space heating, very, very little applications, but you have a tremendous applications and growth potential is there in the commercial and industrial sector. So with this, I conclude my presentation. Thank you very much. Okay. So, and we have seen this commercial sector heat pump has attracted a period of less than 18 months in most cases, and combined heating and cooling applications when we want to convert this heat pump in a both the mode, which has more taker, and large scale deployment awareness on the life cycle cost and the product availability is going to be the major market driving potential. Okay, and the heat pump now it is a HVAC. It comes to HVAC market from the MEP market. So there is a lot of push from the consultant to promote heat pumps on the building applications, and the performance regulation for the heat pump and considers renewable energy device from the society. We are in talk with the government to announce this air source heat pump and a water source heat pump as a renewable energy device, and the geothermal heat has been already under consideration by the ministry. So we are pushing this very hard with the ministry to announce or to have some policy on heat pump as a renewable energy device. So with this, I conclude my presentation. Thank you very much for the opportunities given. Thank you.
Thank you. Thank you.
Okay, thank you very much, Saravana-san.
Thank you very much.
So ではここでですね。
Here, we'd like to welcome some questions. If you have some, please press the hand raise button. You can give us questions either in Japanese or English. Those who have questions, please let us know pressing the hand raise button. No questions? Okay, Saravana-san, thank you very much.
Thank you. Thank you for the opportunity given by Thank you.
Thank you very much.
So, next, we would like to move on to the next presentation. So next, we would like to invite the presenter from Vietnam, from the Hanoi University of Science and Technology, so the Professor Jun. We would like to.
Now, floor is yours.
Okay, yeah. So, good afternoon, everyone. Can you hear me clearly?
Yes.
Okay, yeah. So, now I should share my. Can you see my presentations?
Oh, not yet.
Not yet?
Yes.
Oh, I see. Can you see it now? No?
No.
Why is not appear here? Okay, I'll do it again. Share.
Oh, it's coming. Okay.
Is it coming?
Yes.
Yeah. Di chuyển trang không được. Sống.
Di chuyển trang mình nhấn tam giác.
Okay. Okay, so can you see my presentation correctly?
Yes.
Okay, yeah. Shall I start?
Please.
Okay, yeah, so thank you very much. Good afternoon, everyone. It's great pleasure for me to see again Thomas, Koki, Jun Choi, Pia Chida, and others. Okay, and that is you on here. Okay, as requested by Mr. Koki from Heat Pump Thermal Storage Center of Japan. I'd like to present some information regarding the energy transition and heat pump market potentials in Vietnam. Now, my presentation should cover 4 parts. Firstly, I'd like to give you a briefing on Vietnam energy statistics and then I move on to the Vietnam National Energy Efficiency Program for the period of 2019 with a vision to 2030. And then I want to focus on some information regarding the application of current applications of heat pump and its potential market in Vietnam in the years to come. Now you can see on the screen, okay, that is the structures of total primary energy supplies in Vietnam. And I really put my apology to Thomas because earlier he already sent a message regarding that. Why should we have to use ton of oil equivalent, ton of coal equivalents? But here in Vietnam, you can see that we really heavily depends on oil and coal oil use, the fossil fuels. And this is a very updated information in 2019. You can see here, okay, the total primary energy supplies is around 90,000 kilotons of oil equivalents. Okay, and the use of the energy provisions in Vietnam normally increase, 11%. Yeah, normally in the terms in 2018. And you can see that the average growth rates of total primary energy supplies during that period, I mean, from 2011 to 2019, you know, the normally the average values are around 6.1%, but for coal, it's more or less double, 13.2%. Okay, so. And on the other, now on this screen, you can see the role of the coal, as I mentioned earlier. You can see that the share of coal is increasing sharply. And I mean that in 2019, the coal share in the total primary energy supply is around 50%, 50%. And I use another figure as the index, like the Heifei-Heisman and index, HHI. You can see that that kind of value just increasing all the time. It means the diversification of primary energy supply in Vietnam just reduced. We heavily depend on the coal use. That is the best situation, right? Now, on the screen, you can see that the change in energy import-export difference. Vietnamese people are always proud of having a lot of fossil fuels. I mean, that is very good for the development. But now, since 2015, you can see that the change already happening. I mean that we become the net import, energy import countries. You can see that the net here, the change, okay, particularly in the 2019, the net energy imports account to more or less 40%, exactly 39.5%. So we now depends on the energy import. Here are some figures regarding the electricities in Vietnam. Now, so far, we are normally talking about the energy use, energy efficiency, particularly for the thermal application. But in Vietnam, most of people just think of using the electricities more efficiently compared to the thermal application, because electricity in Vietnam is still, very at the high cost. I mean, that the tariff is very high compared to the other commodities. So here you can see the structures of the power capacities for the installed capacity, and also in terms of the power generation. And now you can see that the total supplies are both for the installed capacity, also for the power generation is increasing all the time. As I mentioned earlier in my previous slide, that the increase, the growth rates of the increasing of the total of the energy consumption just double compared to the the GDP. I want to use another figure just to show that the situation of energy use in Vietnam through presenting some major energy economic indicator, as you mentioned here, as you have seen on the screen. Now the population is increasing, but you may be interested in the values of energy, electricity coefficient, and electricity coefficient. And then in the bottom, you can see energy intensity and electricity intensities. Now we are really high. We use a lot of power, we use a lot of energy, a lot of electricity to produce $1,000. That is the figures for the 2018. I should prepare, I should compare the energy efficiency in terms of, using the energy intensity and electricity intensity with the other countries in our regions. Now you can see that here the Thailand. I use a lot of data from the BP, I mean the British Petroleum statistics, and then there might be some errors, some discrepancy compared to your own data you have got from your own countries. But the trend, you can see that in the large rounds, okay, that the Vietnam in compare with different countries in our region. Energy intensities in Vietnam just 1.4 times compared to the Thailand. Malaysia a little bit lower, and compared to Japan's, okay, here around 4 times higher, and South Korea more or less 2 times. In terms of electricity intensities, more or less the same trends. So it means the energy intensities and electricity intensities in Vietnam is much higher compared to the other, I mean, almost all other Asian countries. That is why we need to follow, the energy efficiency in the futures now. Since we have several Vietnam National Energy Efficiency Program starting from 2006, we have 3 different programs. The first program just started from 2006 and finished in the 2015. And the second program just starting from 2016 up to 2020. But in this period, there has been not much activities on the energy efficiency in Vietnam. And then we restart again the Vietnam National Energy Efficiency Program starting from 2019. And you can see here on the screen that the structures of the implementations of the VNEEP3, okay, starting from 19 until the year of 2030s. You can see here, okay, we have to divide it into 2 phases. The first phase, starting from 2019 to 2025, and the second one just commenced from 2026 up to 2030. And you can see here, the government just monitor all of, energy efficiency related activities. And we have some collaboration, in terms of EVN, Electricity of Vietnam, Vinacomin, PVN, and other social organizations associated to be involved in this kind of programs. The overall objective of the Vietnam National Energy Efficiency Program for the period of 2019 to 2030, you already seen very clearly on the screen. But I would like to try to focus on some selected specific objective. You can see here, we already identified the opportunity to promote energy conservation in all types of sectors that covering the steel industry, chemical industry, plastics, cement, textile, garment, beer and corn, and paper and other things for the period of 19 to 25 and period of 2026 up to 2030. So why, you may have asked me, why you have such kind of figures? Because that kind of figure based upon the benchmark of current status of energy technology have been employed currently, and we compared with the futures. Very interesting here on the screen that the energy efficiency target has already allocated to the different cities and provinces for the periods of 2020 up to 2025. That's a very point that is very good. That is a very good point that every country, every city, every provinces in Vietnam have already committed to implement energy efficiency, but of course with different targets. For the big city, for example, Hanoi and Ho Chi Minh City, the proposed target should be around 7.3% energy saving could be achieved for the period of 2020 to 2025. And you can see here for the other provinces and cities. And until now, around 40 out of 63 localities, cities and provinces, has already issued the energy efficiency plan for 2020 and for the periods of 2020 to 2025. You can see here in Vietnam, we are good in writing resolution. But let's see what should be implemented in the future. That is another issue. Okay, that is another issue because it depends on the resources. We have to depend on the that the manpower. It depends on the economics already available, to availabilities of the money to realize such plan. Now I would like to move on the current heat pump applications and its market potentials in Vietnam. I think that we have a common pictures whenever we are talking about the application of the heat pump. Basically, I have to share, my thought with Mr. Kapoor from India and also from that. Okay, basically we use heat pump for hot waters, and here you can see here for the residential, for the hotel sectors. And normally in Vietnam, in Ho Chi Minh City, they already apply the heat pump to provide hot water in the hotel. You can see here some figures. Technical data I don't want to repeat because I want to save up the time for presenting another things. And also for the sanitary and hot water, also for the indoor swimming also, we apply air source heat pump for providing hot waters. And for the individual household, for the household sector, we also use, but basically for the hot water applications. Now, we have another application for the heat pump technologies in Vietnam. Some of you already visited Vietnam because we have a chance to host some annual Asian heat pump networks meeting. And some of you already seen that kind of system or equipment normally used for the food processing sector, basically for the drying, or dehumidification of the low temperature drying technology. Normally we use for the food processing, for the candy processing, and also for the herbal manufacturing. Also for the use, normally for the for freezing, using basically for the other processing products. And recently we can use the heat pump for stream cartridge heating. I mean, to provide hot waters for the stream, for the pool where we can cultivate stream for export. That is very good applications. And for that, I'd like to show you in more detail about the cost-benefit analysis, because in Vietnam, every local investors, they just mentioned this concern about the effectiveness of the economic investment. Only a few people just think of climate change, think of the energy efficiency, other thing. So here for the current applications of the heat pump, for the stream cartridge heating, you can see that the capacity we use already around 37.9%, kilowatt, and the seawater normally used for the streaming for stream cultivations with the inlet 20. We need to preheat up to 27, 28, and we have to maintain that kind of temperatures to cultivate the stream for the export. And you can see here very interesting that the simple payback periods are less than 3. I mean exactly 2.6 years. So with that, I'd like to come to some conclusion as below. Now. You may see that in Vietnam, now we have energy transition. We have to realize the diversification of the energy supply rather than depending heavily on the fossil fuels. So it means we have to move from the dirty or heavy carbon economy into the clean economy. So I mean that the renewable energy and also energy efficiency was a good way for us to follow, to implement from now until the 2030s. Yeah, I think that some of you, particularly for the people working for METI, they have very good collaborations with MOIT. Recently, the government has launched out the resolution regarding we have to move forward with the renewable energy and also for the energy efficiency. Okay, so the increasing demand for the hot water in residential sectors and commercial building just has been already observed, and that kind of thing will be increasing in the future because they have to reduce the use of the coal or even for the oil fire boilers to provide hot waters. And solar water heater hybrid incorporate with a heat pump. We already have shown some promising option to apply the heat pump for the water heaters provision. And the heat pump application for the food processing sectors are expected to be widely employed to create significant added value, not only in terms of monetary benefit, but also for the quality, of the CDAC export in the future on these sectors. With that kind of thing, we'd like to finish my presentation. I am very happy to take any question from the floor. Thank you.
Thompson, thank you very much for your presentation.
Thank you. Yeah, thank you.
ではここで質問を
Yeah, we'd like to welcome your questions. Those who have a question, so please use the hand raise button on the screen. Seems that we've got a question.
Thomas.
Thomas. Please.
Yes, I have a question that could also be answered by everybody in the room. I think it's very interesting to see that hot water generation is of peak importance in the different presentations that you have given so far. Thank you very much for the information. What I'm wondering is it not quite obvious that if you need cooling all day long, that the waste heat from that cooling process should be used for hot water generation? And I am not knowledgeable enough about your respective national markets, but is that something that would have a market opportunity in Vietnam and the other countries? Thank you.
May I take Thomas' questions? Can I answer a question from Thomas?
Yeah, that was for the last speaker first, and then for Hong Duang, and then maybe if anybody else wants to comment on it, because I think it's so important.
Yeah, thank you very much, Thomas. Okay, thank you for your interesting questions. Okay, here in Vietnam, you may know that we are tropical countries, so basically we need cooling. You know, I mean that the air conditioning system. Okay, for the heat pump, yes, if you use the two times, I mean that the two ways, air conditioner, I mean for the heat, for the cooling and heating, that should be fine. But at present, okay, the electricity tariff is really costly, so the local people cannot afford it. We already realized one study with the financial support from heat pump thermal storage centers in Japan to use of the two sides, okay, air conditioning system. Okay, in the summer we use a cooling effect, okay, and in the winter, basically in the northern part of Vietnam, we have a cooling season, and the winter, so we need heating. But the local people cannot afford electricity tariff. I think, but in the near future, we can see if electricity tariff is a little bit, stable, and the pattern of living in the local people in the northern part of Vietnam, they can afford it. But on the other side, now looking at the commercial building, like apartment, yes, they may use two times of the air conditioner and also for the heat pump, for the cooling, also for the heating, because they barely need hot waters. Thank you. Is it clear for you, Thomas? Okay, thank you, Thomas.
So, June, you have a question.
No, actually, it's an application. I just have some comment on Thomas's question there. Okay, so as a restrained in ISO, is international standardization that we are very, very carefully to discuss to develop the new standard for heat pump water heater. They have the function of the multifunction. Simultaneously, they could provide space cooling and heating and also hot water supply, because there's some very recently it's some Japanese manufacturer, in the China manufacturer, in the Korean manufacturer, they developed the kind of this product, and they try to penetrate the kind of product to the some market, and but it's quite complicated to define and or function. So I think the next couple of years that the market will be so quite increased there. Is simultaneously is a function there. This is my comment.
Can I just add further to Professor? Okay. In India, so I appreciate your questions. Why can't this conventional air conditioner could also be used as a heating, hot water heat pump application? So the issue is the amount of heat output and what is required. Take the residential application. Okay, there are some suppliers come up with a inbuilt hot water generator in their split air conditioner, and that particular air conditioner can provide about 100 to 150 liters of hot water at about 50 or 55 degrees centigrade, which is in the market right now. They are developing it, but it is not penetrated well because of the high initial cost. That is one reason. And the second reason is most of the high temperature, most of the heat pump have higher capacity in the commercial sectors. So they are thinking that cooling is free. If they install a heat pump, the cooling component is free for them. They can able to reduce their air conditioning load by 10 to 15% in the total load of the air conditioning bill. So that is where it is going. For residential sector, still the equipment, so there are some manufacturers testing it, SMEs are testing this combined air conditioner cum water heater, but it is not successful so far because of high initial cost. This is my comments. Thank you.
Thank you very much. Very informative.
So, Fanson?
Yes.
You want
May I?
something? Yeah, please.
I just have one comment. Okay, I mean that for all the presentations we already mentioned that the major applications of the heat pump basically used for the for the hot water provision production. Now, I agree with Mr. Kapoor from India that even in Vietnam, the heat pump will be used for the low temperatures application. I mean that up to 60 to 80 degrees Celsius. Now, in the presentation made by a delegate from China and even from Japan, you already mentioned about the application of the high temperatures for the heat pump, particularly in the industrial sectors. I think that kind of issues we badly needed. You know that in Vietnam, is still using a lot of coal-fired or even oil-fired boilers for the hot water provision. So in this platform, I mean, within the Asian heat pump network, can you provide us some guidelines and some applications, some case study on how successful the application of the high temperatures heat pump application. Even Thomas, I think you can give us some guidelines, some suggestion, recommendation on how we can move forward to replace gradually heat pump instead of using the coal or oil-fired boiler in industrial sectors. Thank you. Can you hear me clearly?
Okay, thank you very much. So, では続きましてで
Okay, I'd like to move on to
presentation. では続きまして
So next, we would like to move on to the next presentation. So this is the presentation from Indonesia. So I would like to invite Mr. Agas from Heating, Cooling, and Thermal Fluid Technology, Indonesia.
Now, floor is yours.
Yeah, thank you very much. Good afternoon, everybody. Good morning for Thomas. Yes, so I'm last presentation. Let me share my screen. Okay, can you see?
Yes.
Okay. Okay. So first slide is that our government try to electrification of the people in Indonesia, and the target is now almost 100%. So why is not 100% yet? Because the new couples have more housing, so we catch up with the electrification in all of the country. So this is from the electricity company, and this is from the Ministry of Energy and Mineral Resources, so almost the same. And of course, what's the meaning of this slide? That now our Indonesian family has electricity, which means that we have now refrigerators, iron, light, washing machine, water heater, etc. So consumption of the electricity still high. So this is the forecasting for 2030. So you can see this is right now, and then the green one is in 2020. Sorry, now this one is the green one, and 2025 we forecasting like this, and 2030 in the blue one, and you can see we still consumption for household, because the electricity, peak electricity is come at night. Yeah, it's about 8 o'clock in the afternoon. So this is the projection of energy consumption in Indonesia. 2000, 2014, and 2030. Transport, industry, and others. It's becoming higher. Sorry. So this is the fuel mix in primary energy supply. So from coal, we are needing more coal now, and also bioenergy, hydropower, oil, bioenergy, natural gas, geothermal, all resources, we use it to supply the electricity for the country. Now, this is the annual installation of renewable power in Indonesia. So solar power, hydropower, geothermal, bioenergy, marine energy, wind power. So all this from previously 2011 to 2015, and then the yellow one is 2016 to 2030, and the green one is the average. And you can see the solar power is becoming more and more friendly in Indonesia. And the projection of the renewable energy consumption in year 2030. So this is from hydropower, onshore, bioenergy, etc. And also transport, power and heat and other direct uses. And the energy conservation roadmap is like this. So we're still using million barrel of oil equivalent, Thomas. So yeah, we should change this one, but we still use it at the moment. So this is the energy conservation roadmap until 2035. Yeah, it's almost 500 million of barrel equivalent. And the government program for energy conservation, energy management is number one, and then number two is standardization of energy efficiency and development of energy conservation project, and then awareness and energy efficiency award. And this is also the roadmap for minimum energy performance standard. And you can see the swaballast lamp, air condition, and air condition equipment. It's already done in 2018. And last year, 2019, we already have the refrigerators, rice cooker, fan, electric motors. And last year, television, a blender, iron, also already done. And starting this year, we start the standardize the boilers, showcase, dispenser, water pump, washing machine, and chiller or transformer. We also establishing the human resource. So we have the energy managers training and also energy auditors. So the energy manager is someone who is given duties and responsibilities to coordinate the application of energy management in industry and buildings, while the energy auditors is a person who has the qualification according to the competency standard to conduct an energy audit. So we have almost 800 in the energy manager and 900 in energy auditors. And the future energy efficiency project is the government continue the energy management and energy efficiency program, and also energy efficiency of electric vehicle, application of fuel economic standard on vehicle, application of zero energy and emission building, and also energy efficiency for cooking. And the strategies by the government to accelerate energy efficiency is to strengthen and harmonizing policy and regulation to support energy efficiency in Indonesia. And then energy efficiency program will also focus on the supply side, including power generation, the oil and gas industry, and the mineral and coal industry, in addition to the demand side, and also giving the incentive to accelerate the energy efficiency project and reduce the project risk. Also, energy efficiency project need funding support from the government and private sectors by applying the public-private partnership, and also implement energy efficiency pilot project with the project financing scheme. Funding support also exists. This is the two company, it's developed by the government, and also invite the international financial institution. And then the number 7 is conduct targeted awareness raising and stakeholders knowledge exchange activities. And the projection of greenhouse gas emission in the refrigeration and air conditioning sector, because we are in the equator, so we use a lot of refrigeration and air conditioning. Almost 60% of energy we use for air conditioning sectors, especially in the office building. And this is the projection in million ton of CO2 equivalent. It's up to 2050. And in 2030, this is what will be dealing, what we have to do with the gas emission. And BAU is the business as usual scenario. And the other one is unitary air condition, chiller, mobile air condition, domestic refrigeration, commercial refrigeration, transport refrigeration. It's this total emission. And in 2050, we have to deal with this, the mitigation potential of the Indonesian refrigeration and air conditioning. This is the prediction of annual sales growth rate for unitary air condition. So ranging from 3% to 15%. The 3% is the chillers, and the 15% is the commercial refrigeration. So it's quite high because the existing in 2015 is already quite high. So this is the condition of 2010 to 2015. The left one is the split residential subsector, and the right one is the self-contained air condition, split commercial, duct split residential, rooftop ducted air condition, and multi-split air condition. And labeling for energy saving in Indonesia. So we use star, and from 1 star to 4 star. And it's typical heat pump water heater we use in Indonesia. So we use quite a lot with the solar power, but of course in the apartment, in the hotels, we use electric heat pump water heater. And there is no data for the heat pump water heaters, but it's predicted that based on the growth of the property, so the property, it's sorry, this one is mistake, it's 5%, and in the last 5 years. So the growth of heat pump water heaters is about 2%. So from 5% house built in Indonesia, the growth, 2% with the heat pump water heaters. So therefore, we propose that because as we can see, there is no intensive inventory for heat pump water heater appliance, not even in the government target. As you can see in the previous slide, the property growth is less than 5% in the last 5 years, and no data concerning heat pump water heaters. So therefore, we propose to have more research study and do the inventory concerning heat pump water heater in Indonesia. Thank you very much for listening my presentation.
Thank you.
Thank you very much, Agus-san. Thank you for your presentation. ではここで質問を受けいたし
I'd like to welcome your questions, if any. Those who have a question, please use the hand raise button.
トーマス。
Yeah, I'm sorry. It's a quick question. I'm notorious for asking questions. Even in Brussels, they say, "Oh, Thomas is in the room. He will ask questions." But how much are you working with industry? I'm thinking collecting market data is not a scientific exercise. It's an exercise where the industrial players have to report data. So it's more about the process of getting them on board than about scientific rigor. Would you agree? And is that an approach that you're looking into?
Yeah, what we did in other association, ASRE, for example, we do the market survey by doing the focus group discussion, inviting the manufacturers, and also the working with the the importers data, and then we confirm with the the agent, etc. So it's quite difficult in Indonesia to collect data. So, for example, in the inventory for refrigeration and air condition, it took about 1 year to collect the data.
Oh, okay.
Yes.
Thank you.
So,
any other questions? Okay, if not.
Thank you for your presentation. So,
Thank you.
では続きましてで
I'd like to move on to the next presentation. A presentation from Japan. So I'd like to introduce Akito Machida, who's the committee chair of AHPNW, please.
Can you see my screen? Yes, sir. Good afternoon, ladies and gentlemen. I am Machida, chairman of the Dissemination Committee for Heat Pump Water Heater to Southeast Asia and the Heat Pump and the Thermal Storage Technology Center of Japan. So, and now that we are getting the more and more questions, so I am getting a little bit nervous. However, today, I would like to report the Dissemination Committee's actions for the dissemination of the heat pump water heater to Southeast Asia based on the Tokyo Declaration of Asia Heat Pump and Thermal Storage Technology Network, AHPNW. First of all, in October of 2017, when we had the AHPNW Tokyo workshop, the 7 member countries signed and announced the Tokyo workshop declaration with an aim to spread the heat pumps. Member entities decided to actively encourage the government of each other member country to define the heat pumps as renewable energy sources to reduce the CO2 emission. And also, we decided to take an actions to disseminate the heat pump as the dissemination committee. So at the AHPN Tokyo workshop, in order to implement the Tokyo Declaration, since 2018, heat pump, water heater, and the thermal storage technology centers were decided to be the secretariat, launched the dissemination committee of the heat pump heat waters, the 2 Southeast Asias, consisting of the 3 industries of its member companies, refrigeration and air conditioning industry, construction industry, and energy industry, and engaged in actions towards the dissemination of the heat pump water heaters to Southeast Asia. So I'd like to explain what the dissemination committee did over the past 3 years. In the initial year, or 2018, the committee compared the basic data of each ASEAN countries, clarified the challenges to disseminate the heat pumps, and set its action goals and the specific action they should do. And in the second year, 2019, it analyzed the potentials and the needs of the disseminating heat pump water heaters, mainly in the building sectors of Vietnam, Thailand, and Indonesia, by studying the documents of each country and doing interviews and exchange of opinions. In the third year, that is this year, it deep dived the important issues to disseminate the heat pump water heaters, which had been recognized through the previous 2 years' activities, and compiled the direction of the solutions for disseminating heat pump water heaters in Southeast Asia going forward. Heat Pump and the Thermal Storage Technology Center of Japan is going to implement actions to disseminate heat pump water heaters to Southeast Asia through midterm action plan made based on the proposal of this dissemination committee. The dissemination committee clarified the issues for disseminating heat pump water heaters to Southeast Asia and put the priorities to actions the committee will take. And it also said that making a proposal of the energy-saving models, catering to the needs of each country as a goal to disseminate heat pump water heaters. To achieve this goal, it decided to implement the following 3 actions. The first, the improvement of awareness. And the second is the understanding of the local needs. And the third is to establish the collaborative relationship with the local heat pump related organizations. So the dissemination of the committee narrowed down the targets of the dissemination of the heat pump water heaters. As we heard in the discussion, originally at the speaking, heat pump water heaters needs were wondered, meaning that whether we can find the needs, so that we decided to narrow down the target of the dissemination. And then for the household use, in the Southeast Asia, we cannot see the Beijing the cultures as in Japan. And also for the industrial application, heat pump manufacturers offers the different quality of the products. So we decided to focus on the industrial use, including a hotel and the hospital, because we can find it easier to set the operation pattern. For the targeting countries, we studied the basic data about whether we can find the counterpart or the population or GDP or weather condition and JCM the business the track record. We decided to target the 3 countries, Thailand, Vietnam, and Indonesia.
On-site survey was conducted in order for us to correctly understand the needs for heat pump water heater for commercial buildings, mainly hotels and hospitals in Vietnam, Thailand, and Indonesia. In this survey, we talked to construction companies, building owners, individual companies, such as design offices, government offices, and industry associations where the heat pump is being promoted. The survey was conducted in Hanoi in Vietnam, and Bangkok in Thailand, and Jakarta in Indonesia. Also in Vietnam, the promotion the promotion committee members visited Hanoi in 2019 and also in 18 as well. So we held a workshop there in Vietnam, especially the one we had back in 2019. We had a large audience, and mass media covered that as well locally there in Vietnam. Other than that, we toured around the heat pump related facilities and met with the government officials and related organizations as well. And on this slide, I'd like to discuss the penetration potential of heat pump water heater. This pie chart represents energy demand for hotels in Vietnam. In Vietnam, which is rapidly developing, there's a rush of constructions of commercial facilities in line with the improvement of living standards. Energy consumption of water heater is number 3, after air conditioning and lighting, and it accounts for 10% of the total energy, which is, in order for them to achieve energy saving, this is considered as a very important point. But penetration of the heat pump water heater is quite limited now. Here on this slide, you see the trend of foreign tourists in Thailand from 2009 to 2018. Thailand is a tourism-oriented country, and the number of tourists has been on the rise year after year. And in order to deal with this increasing number of tourists, there are lots of openings of the new hotels and expansion as well. And number of hotels in Indonesia shows upward trend since 2004 till 2018, especially 2018. Number of hotels rapidly increased. 28,230 hotels and 712,202 rooms available there. So we see the huge increase in 2018. And in Bali, which is a tourist resort, exceeded Jakarta, which is a special state, in terms of the number of hotels. So region-wise, Bali is number one in terms of the number of hotels. So looking at all those data sets, including heat pump, water heater, introduction of heat source. So we focus on the processes such as planning and design studies and conducted on-site survey. In this survey, we asked them to provide a hypothesis concerning the domestic business environment, and we found out that the introduction process is quite similar to that of Japan. So for new introduction, specification at the time of a basic design phase, when they fix the basic configuration of the system, is adopted. So therefore, it's important to make a proposal to enhance the awareness of design offices on the system and their judgment criteria. When it comes to a modification of the existing systems, engineering manager or building owners make a final decision based on a certain investment criteria. For this, we realized that it's important to work with engineering companies. This is a summary. So in those three-year activity, as a part of the activities in Southeast Asia Heat Pump and Thermal Storage System Promotion Committee, we did some studies on the challenges and solutions to further promote commercial heat pump targeting hotels and hospitals in Vietnam, Indonesia, and Thailand. In Vietnam, Thailand, and Indonesia, new constructions of commercial buildings such as hotels are booming according to the improvement of their living standards. Since they are paying more attention to energy saving, we can expect heat pump water heater will be introduced into those buildings. However, penetration of heat pump water heater in those countries or awareness is limited to the related organizations and design offices and engineering companies. In the future, heat pump and thermal storage center. Heat pump and thermal storage center will address issues raised by the promotion committee, not only focusing on the heat pump water heater, but also on the heat pump and thermal storage system on the whole, so that we can make a contribution to solving issues we face to climate change. To be more specific, we'll work hard to increase awareness among government offices and concerned organizations and parties and potential users through various occasions such as seminars. Well, this is end my presentation. Thank you very much for your attention. Well, thank you very much, Mr. Machida. I'd like to welcome questions. Those who have a question, please press the hand raise button.
Hi, Thomas.
Did you try to contact other stakeholders? We are now looking in Europe to talk to city organizations such as ICLE or the Energy Cities or Eurocities. And we are also talking to building organizations that are responsible for building these big hotels, and to hotel chains and to consultancies. In Europe, that is Ramboll or Arup, you know better in your region who is doing this work. But I would suggest that it is important to talk not only to experts, but to talk to the people that have to use the product in the end. Thank you.
通訳ができた。他のどっかステークホルダーと組むつもりはないか。例えば実際ものを使ってる人たちとかそうですね。
And this time, as HPTCJ, I came here to present what we are doing. So now that we are working like a company, so we are not in the stage where we can work with the other stakeholders.
Thank you very much.
まだ町田さん質問があるみたいなんで。
Seems that you have more questions.
Yes.
Yeah. Okay. So just additional information that if you add the apartment owners, I have a data that the growth of the apartment unit every year is about 50,000 also. So it's similar to what you presented, Usman. So the data you presented could be double if you add the apartment housing, because usually every unit in the apartment has a water heater also. Thank you.
ありがとうございました。現地
Thank you very much for a comment. So when we conducted the on-site survey there, high-rise apartment or condos, there's a demand for a water heater. That's what I heard. And in this activity we talked about, we focus on the hotels and hospitals, but in the future activities, so we'd like to include the apartments and condos, with high-rise condos or apartments as well. So that's something we need to focus on.
はい。他にご質問等ございますでしょうか。
Any other questions? Okay, if there's nothing. So we didn't have any time for question and answers related to presentation from Thailand. Those who have a question on the Thailand presentation, please use the hand raise button.
はい。ではないようですので、次の
Okay, there's no more questions. Let's move on to the next presentation. Mr. Machida, thank you very much.
This is the last lecture in today's program. We would like to invite the Professor Saito of the Waseda University, titled the role of the heat pump towards the net zero emissions. Mr. Saito, the floor is yours. Can you see my screen? Yes, we can see your screen. This is the last lecture for today's section. As the moderator explained, my presentation title is the role of the heat pumps towards the net zero emission. I'm Saito from Waseda University. As you may be aware, towards the net zero emission, the world has just moved. That is the current situation. Out of the 196 countries, 120 other three countries declared they will achieve the net zero emission by 2050. And the number of the countries who are declaring this has been increasing every year. The point to realize the net zero emission is the decarbonization on the supply side and the electrification on the demand side. So, when we look at the supply side of the energy, and this is the supply side or the power generating the sector status. In this the sectors, the decarbonization has been on the way, and the renewable energy has been adopted very early. As you can see on the left-hand side, we can see the two other graphs. It shows what kind of the primary energies have been used for the energy supply towards the 2030. Upper graph shows the advanced economies the status, and the bottom shows the developing countries the status. And the green shows renewable energy. Yellow is the nuclear. As you can see, this the graph for coals. Consumptions is intended to decline in usage. In particular, for the advanced countries, they try to bring the coal use to zero. For the nuclear power, as it's shown here, but for the renewable energies, it is expected to grow in its usage. So the question would be, what is going on the demand side? And this is the report of the IEA. In this report, decarbonization key points and the scenarios were explained. There are 4 points. The one is electrification, CCUS, hydrogen, and bioenergy. As I mentioned before, electricity has been mentioned also in this report. In order to realize electrification, as you know, going forward, we have to promote the penetration of the electric vehicles, and also for the industry and the building areas. Penetration of the heat pump is quite necessary. That has been mentioned in this report. And this is about the IRENA, that is the International Renewable Energy Agency. And this organization also has been issuing the strategies required for each other sector. It's quite clear. I don't have enough time to explain everything. However, as you can see that the red the finger arrow shows, I would like to explain these portions. We can see that the years from the 2030 to 2050. First, in the sections with the red hands. And that is talking about the status of the introduction of the renewable energy towards the 2050. Currently, the penetration of the renewable energy is 26%, but by the 2050, we have to increase that ratio to 86%. For this portion, it has been on track. Meanwhile, when we look at the demand side, heat pump has been said to be very important. When we look at the current situation, there are 40 million units installed, but by 2050, the installation units needs to be increased by 10 times the larger. However, it's off track, as you can see, so it has been delaying. So looking at these data, it's clear we have to install more the heat pump water heaters. In order to realize that, we need to take an action to increase the awareness and give the financial support which are indispensable. And all the reports are talking about that. And this is Japan's policy. This is the measures to never fail to achieve the energy mix by 2030 issued by METI. So what should we do? So for the industrial application and the household application, what we should do has been described. For the industrial application, energy intensity improvement has not been progressed. For the household application, it's quite difficult to achieve the target just by improving the energy saving efficiency of the home appliances. So that the Japan is planning to introduce the top runner the system or program, or the Japan plans to promote the zero emission house. When we look at the more challenging area for the industrial application area, beyond the border of each of the companies or industry, the supply chain and the different industries needs to be collaborated. And for home and commercial application, we need to use the IoT and the AI to improve the total efficiency of the system. And to each house, we need to increase zero energy houses. So that's what has been mentioned in this the government measures. And this is the project of the NEZO. And that is the thermal management materials and the technology the research associations project. So one of the project is the heat pump development with the temperature durability up to the 200 degrees Celsius. And the other point that they are developing is the heat pump simulator for the industry application. And Waseda University has been involved with this simulator. So I'd like to briefly explain what it is. Here, there are the two simulators that we are developing currently. One the simulator is the heat pump standalone the simulator. So for this, if we replace the combustion boiler with the heat pump, what kind of the energy efficiency we can get? That's the data that will be coming out of this the simulator. For the heat pump, the question is whether we will circulate the hot water or not circulating the water, or that we might use the boiler or replace the boiler, or whether we use the preheat of the boiler. And also for the heat the usage, do we use the heat boiler for heating, or both for heating and cooling? If we classify the patterns, that we can get the 8 patterns, and for each of the patterns, we try to get the energy efficiency. And through these the tools that we can easily analyze and get the answer for that. So here we provide hot water in a non-circulation method, and the boiler will be used as used for free heating, and then the heat pump is used for cooling and heating. We tries to calculate the result, and we select the pattern in the middle of the screen, and then the system make a comparison. And then we can see that the energy use for each hour, and the energy use, as you can see, has been changed. For the case when we use the boiler and the heat pump, and the CO2 emissions gets different for each case. So these the simulators can do this. And one of the things that we are using is the integrated heat pump simulator. Once the heat pump is installed, we need to have the auxiliary equipment. So that many people ask how much the efficiency improvement that we can get. So in order to get that answer, we are developing this integrated heat pump simulator. And this is a heat the pump installation to send the hot air to the painting process. Right-hand side that shows the overview of the simulator. That is a GUI. So what we have to do, the devices such as the fan or heat pump and chillers are displayed. So you just click one of them and then connect the system or the devices they are connected. If we use this, we can see the monthly energy the consumption after and before the installation of the heat pump, and also that you can get the analysis result of the energy use before and after heat pump installation, and then you can see that how much the CO2 the consumptions, the energy consumptions declined. So this is a very effective way to see how the efficiency of the heat pumps are. Actually, currently the heat pumps have not been penetrated, so that before installation, people that can analyze the possible usage of the energy by using the heat pump. So I believe that this will contribute a lot to the installation of the heat pumps.
From here, I'd like to talk about what about the usability of the heat pump when the renewable energy is introduced. Looking at this slide, the morning, afternoon, evening, at nighttime, there's a green portion. That's a demand side, and what's shown in black, that's the demand side, and supply side and demand side. That's what's shown on this chart. So as you know, the renewable energy is really unstable. So if it's introduced, so the climate difference and the regional differences, so supply side and demand side, it's quite difficult to maintain a good balance, and the gap will be wider and wider. If this happens, so as shown here on this, so if there are lots of sunny days during daytime, energy supply will be very high. So supply will be more than the demand. It happens sometimes. So in this case, how we need to adjust that properly, otherwise we will have a power outage. So if that happens, so supply side, we need to increase or decrease the renewable energy side, which we cannot do. So we need to absorb it on the demand side, we have to place a good mechanism in place. So if I talk a little bit more using this slide, demand response, that's how we call it. So there's a seesaw here. So renewable energy, which is unstable, if you accumulate those, if it becomes heavier, and the supplies, it will be inclined to the supply side. And if there are lots of cloudy days, demand side will increase. So this balance will be ruined. So that's something we need to understand as for the future demand and supply of the energy. So as we've been discussing, we need to strike a good balance, which is called a demand response. That's very important. So for example, renewable energy introduction increases dramatically. If that's the case, so on demand side, they have to keep using it. 50 watt, it's called a posi watt, store and store electricity and heat and operate equipments. On supply side, if it goes down, that's negawatt. We need to stop the operation of the equipment and we have to discharge it. Discharge the electricity and discharge the heat. So we need to take a good balance between the supply and demand. So how can we realize this? So what we have in our mind is that the electric vehicles and storage battery and operation adjustment in the plants and heat storage as well. That's how we are going to observe. So heat storage, for example, existing heat storage air conditioning system may be usable for this application. So heat storage air conditioning system gained popularity once in the past. At nighttime, there are some open capacity of electricity. Not so many people use electricity. So if you operate the heat or thermal storage air conditioning system, you can make the peak shift. So you can level the load. So when it comes to the supply is really big, we can use this for demand response. We can use it. So in a different way, during daytime, we store the heat or electricity, absorb it, and use it for other time. That's something we can do. So in Japan, 750,000 kilowatt system for this heat storage air conditioning system is introduced. That's equivalent to a large power generation plant. So we need to properly utilize this for the renewable energy introduction. And what you see, innovative environmental innovation strategy. So what is that? So this is based on the long-term strategy as a growth strategy according to the Paris Agreement and also Integrated Innovation Strategy 2019. And it will create, they have the Innovation Action Plan. So by 2050, what kind of innovative technologies that have to be introduced? So there are 5 fields that are set and 16 technical challenges. And 39 detailed themes are set. So in this, so R&D investment, that's called acceleration plan. And together with the world leader, we have to communicate lots of messages or communicate important information to the public. That's the Zero Emission Initiative. So industrial, residential, and other. So cross area is one of the very important points. And if you take a closer look at that, one, and AI and IoT will be utilized so that we can link various equipments to achieve energy saving and milio energy and renewable heat energy usage will further expand in the future, or unused heat and renewable energy have to be utilized more than now. So there are some demonstration example I'd like to talk to you about. And this is the NEDO project. And Daikin did this demonstration in Portugal. That's a demand response demonstration. And they introduced this at 4 locations in Lisbon City. So including renewable energy equipment, and there are some other equipments as well. Daikin's, the multi-building system performing demand response, and then maximize the introduction volume of renewable energy. That's the demonstration they conducted. So as I said earlier, so if we have the heat storage type air conditioning system, that will strike a good balance between supply and demand so that we can effectively utilize renewable energy. So demand response. Of course, IoT and IoT are the essential parts to do this. So energy saving has been realized successfully. And in this is in Nagoya City, the urban redevelopment example. At the same time, this is a sewage treatment facility modification took place as well. So for the redevelopment, there's a canal, and there's a water pump there. And using the reused water from the sewage system to purify the water there. So that's really good for the environment. That's one thing. And utilizing the heat of the sewage water system will operate the heat system in a very, very effective way, if an efficient way. So that's what they did. So 300,000 square meters, which is really big. And this was applied to a large project. So they could save a lot of energy by doing this. So coming to the end. So heat pumps, making some heat on making some cooling. So introduction has been accelerated in the past, but however, so in the future, renewable energy will be introduced more and more. So how to utilize the heat pump and ideas or strategy for the heat pump will be very much different what we have now. So as I've been talking about unused renewable energy and heat energy, which have not been used properly in the past. By introducing the heat pump, we can convert those into a usable energy. So we can really utilize those effectively. That's what's realized by the heat pump. And this is another point. So IoT and AI will be utilized to link various equipments. And if you can use a heat pump to realize this. So those are the 2 use cases of the heat pump to really realize the decarbonized society in the future. That's what we think. Well, but last but not least, so this is the illustration of what I talked about so far. As I said earlier, AI and IoT will be further utilized in the energy system as well. So there's lots of energy supply pictures there. So houses, plants, and buildings. So they are all connected using AI and IoT, so that supply and demand balance will be taken properly, so that they can utilize renewable energy. So heat pump will fill in the gap between supply and demand, and unused energy will be converted to effective energy. So that's what heat pump will do for us. So zero emission society or decarbonization society, heat pump will play a very important role. So the people in Asia, I'd like to work with you in the future to further disseminate and promote heat pump together. Well, thank you very much for listening.
Thank you, Prof. Saito. Yeah.
斉藤先生、ありがとうございます。
Thank you very much, Professor Saito.
So that's all for today's presentations. So lastly, we would like to get the Vice Chair of our center, Mr. Hayashi, to give you closing remarks. So, thank you very. So in order to close the ninth AHPNW Tokyo workshop, I would like to have a closing remark. I am Vice Chair Hayashi of the HPTCJ. First, we got Mr. Novak for the key the speech and also the Sasaki HPTCJ and the President DEDEAMU from the Thailand and the Southeast Asia dissemination of the committee for the heat pump to Southeast Asia and the representative from the governments. We very glad to close this meeting with the great support from all of you. So for today, at the beginning, Mr. Novak, the Secretary General of the AHPA, talks about its effort to introduce the renewable energy under the EU Green Deal policies. And along with that, he said the heat pump installation will be expanded. And then the HPTCJ explained about the Tokyo Declaration and the current penetration status of the heat pump. And the member countries talks about the initiative related to the Green Deal policies and others. In many countries, there are many other initiatives towards the decarbonization and to introduce the renewable energies. About the status of the installation of the heat pump, there are some countries where they are seeing that the expansion of the heat pump under the decarbonization of the policies, and there are also some countries where we can expect the expansion of the installation. And from Japan, we got the report about the committees, the initiatives to expand the heat pump water heaters to Southeast Asia. So in a special lecture, Professor Saito from Waseda University talks about the positioning of the heat pump. The role of the heat pump is not limited to the energy conservation equipment. And in order to expand the unutilized renewable energy, it's quite plays quite important roles in the system of the whole renewable energy network. As you know, currently so the last year, 2019, it was recorded 410 ppm. So now the Earth is facing the anthropocene era. That is one of the academic theory. So under the Paris Agreement, we shouldn't waste time to work on the decarbonization. So the 123 countries have already declared to work on decarbonization. In order to do that, hydropower technologies or other technologies will play an important role. However, when it comes to the feasibility economy, there are some uncertainties. So that it's quite important to make all plans feasible in the society. From that perspective, I believe that the utilization of the heat pump is very important. As we heard in the presentation, the installation status of the heat pumps are different country by country. However, for the world to achieve the decarbonization of the societies, we can learn from each other. Through this work at the shop, we need to understand the current status, and I believe that we understood the current status and share the status. For all the countries to work on the penetration of the heat pump, we would like to continuously work on initiatives. I wish that all the participants had learned something. So lastly, towards the decarbonization, I hope that you will take actions. With that, I would like to conclude my closing remarks, and thank you for your participation.